In this video, I'm going to walk you through Lesson 5 of Unit C1 from Open Syed. Okay, this is actually the beginning of the second lesson set. The first lesson set was all about how and why the sea level is rising. And now we're going to talk about design solutions. And so this lesson set, it's 3 lessons, is all about what solutions could help slow down ice melt. So we navigate into the lesson by considering where these design solutions might be the most impactful in Greenland. And so there's a slide to support you. There's also a handout that you can pass out to students to have them look at these red and orange shaded areas. The darker the red, the more ice melt. And so they identify a couple places in Greenland where a design solution would be very impactful. And then we are introduced in one of those areas that students identified to the Iluissat Glacier. And so this glacier is located in Greenland. It's actually one of the fastest melting locations in the world over the past 150 years. So a lot of research has been done there, a lot of photographs, but also this is a site where engineers have proposed some possible design solutions. And so we begin by watching a time-lapse video of the ice melt. And so you'll see it's dated and it has calving or different parts of the ice kind of falling into the ocean. And so you'll play this. There's not much to it other than it's like a live stream cam, but it's not live. And then we're going to analyze some satellite images. And so this actually, there's a handout for this too that you can pass out. You can see that the lines show where the glacier was at different time periods. And so it's really gone back in time into and recessed into the land. And so we're just really getting to know this glacier. And then we consider some priorities. There's a slide to support you on what you think would be important in a proposal. What would you value if you were looking at a proposal to evaluate? What would you use to make your decisions? And so we're kind of moving into that engineering design process a little bit of evaluating solutions. And we introduced 2 different solutions. Now there's a handout for this. And you can see there's a summary of the glacier up here, and then it talks a little bit about the topography of Disco Bay, where this glacier is located. The first solution is a berm. And so basically this is a 100-meter high wall that's going to be built. And if I scroll down, there's an image here that's going to be built on top of this sill. And so the first proposal is called a berm solution. They would come over here and pick up a bunch of gravel and stuff off the ocean floor, add it to the top of this sill, and then cover it in cement. So it's going to create kind of like a wall in the ocean. So that's one solution. The other one is spreading a layer of microbeads. And so this would happen in the fresh snow. I wouldn't have to be there year round, but when they have that fresh snow right after winter going into spring to help reduce the melt of that fresh snow. Now, you will notice when you look at this, there's a couple things. This warm water right here is coming over the sill and into the area that's touching this glacier. So that deep, warmer water and glacier are interacting right here. So that's kind of something that's important to point out. You also have some shallow, cool water interacting with the glacier here. And then this is the line between that cooler water and deep, warm water where it interacts. And so just kind of going through this diagram to set up the idea of how these solutions might work to slow down the ice melt. So we then hear from some different rights holders, and there's a video here about being healthy as an Inuit, and this is not an open side video. It comes from the Inuit community, and it's pretty long, so you can just show the first 4 or 5 minutes. There's also a handout that goes with it that kind of summarizes the big part, but this is about really recognizing who lives there. There's indigenous communities that have lived there for a very long time. And so how do they feel about these design solutions? And so here is a handout you'll print out, and it is going to show a bunch of different views from concerned citizens. They're worried about the environment. They're worried about the long-term effects. They're worried about how this is going to affect their fishing. So this is all bringing into the forefront that we have to consider a lot of different people's opinions on these solutions, not just the engineers. So then each half of the class independently creates an initial model. So you divide the class in half. Half of them are going to create a model. You can give them big chart paper or whatever materials you have, whiteboards maybe, and they're going to draw a model, an initial model about how they think that solution will work. And so half the class does the berm solution, half the class does uh, the microbead solution, and then they're going to share with each other. They're going to go into small groups and they're going to take turns sharing their initial models. And they're wondering what makes sense and what does not make sense about what's in these models and these proposed solutions. So then we come together and we make a class consensus model with both of them. And the consensus model, we're just kind of trying to capture student thinking about how these solutions will work. And then we bring the lens in of energy. And so we're going to add in the energy diagrams. So you can see that we have these energy diagrams with the sun is transferring energy into the system. We've got the boundary of the system using those energy modeling rules. This would be the boundary of the solution. So we've got beads on the ice within the solution. And then we have some of that energy is being reflected into space. Maybe we're not quite sure, so we add a question mark. Maybe we're not quite sure how the energy is going from the beads to the ice or taking energy away from the ice. So whenever your students have some type of disagreement or uncertainty, it's great to put a question mark to show them we don't understand this fully and we need to investigate this more. And so the whole point of this is capturing ideas, but also showing us that we can't totally explain what's happening to the energy and why these solutions work. You can also see down here, and don't worry if your model doesn't look like this, but we've got some motion of particles. We're using those arrows to represent motion. So that warmer water has more energy, more motion in the particles. The cooler water, less motion, smaller arrows. And again, we've got two energy systems. We've got one with the berm, one without the berm, how energy is being transferred within that design solution. So do the best you can with what students give you. If they are different from class to class, that's perfectly fine. Okay, so once we've realized that we can't explain everything on our initial models, we're going to go back to the driving question board and we're going to add some questions. This is sometimes called a re-anchor. This is actually questions about the design solutions now. And so we're going to add some new questions in case there are not any questions on your driving question board about the solutions. We're going to add them now. All right, that's it for lesson 5. Let's talk about materials prep. It's pretty easy, just a few copies.